Hello and welcome to this video. Today I will try to explain to you something about laws in electrical engineering and what can you study if you decide this to be your major. I will explain to you the Kirchhoff's voltage and current law and the application in solving real-world problems. So, in this major you can study the laws like the Kirchhoff's law. Kirchhoff's law is one of the fundamental laws in electrical engineering. Gustav Robert Kirchhoff was a German physicist who contributed to the fundamental understanding of electrical circuits. Kirchhoff's circuit laws are two equalities that deal with the current and potential difference, also known as voltage, the lumped element module of electrical circuits. They were first described by Kirchhoff in 1845. This generalized the work of Georg Ohm and preceded the work of Maxwell. It is widely used in electrical engineering, and they are also called and known as Kirchhoff's rules or Kirchhoff's laws. Kirchhoff's laws are the two laws necessary for solving circuit problems. For simple circuits, we have been applying these equations almost instinctively. The first Kirchhoff's law states that the voltage around a closed path in a circuit must sum to zero. The voltage drops being negative, following a current through a resistor, while the gains are positive going through the battery from the negative to the positive terminal. The second Kirchhoff's law states that the sum of the currents entering a node or a junction must equal to the sum of the currents exiting a node. The first law is a simple statement of the meaning of the potential, and the second law is the statement of current conservation mentioned before in the Ohm's law lecture. For the node of the left on the right side, we can see that I1 current is entering the node and the I2 and I3 currents are going out of the node. So the relationship between is simple, and it states that I1 is equal I2 plus I3. Kirchhoff's voltage law is also called Kirchhoff's second law or Kirchhoff's loop and Kirchhoff's second rule. The direct sum of electrical potential differences or voltage around any closed network is zero. Or more simply, the sum of electromotive forces in any closed loop is equivalent to the sum of potential drops in that loop, or the algebraic sum of products of the resistances of the conductor and the current in them in a closed loop is equal to the total electromotive force available in that loop. It can be stated as the sum of all voltages inside a loop is equal to inside a closed loop in a circuit is equal to zero. Here the n is the total number of voltages measured. The voltages may also be complex. This law is based on the conservation of energy, whereby voltage is defined as the energy per unit charge. The total amount of energy gained per unit charge must be equal to the amount of energy lost per unit charge, as energy and charge are both conserved. Kirchhoff's second law is also known as Kirchhoff's first law or the Kirchhoff's point rule or Kirchhoff's junction rule. The principle of conservation of electric charge implies that at any node or junction, the sum of currents flowing into that node is equivalent to the sum of currents flowing out of that node, or equivalently The algebraic sum of currents in a network of conductors meeting at the point is 0. On this example, we can see that the current entering this junction are the currents I3 and I2, and the currents flowing out of the junction are I1 and I4. So the relationship using Kirchhoff's current law is that I2 plus the I3 is equal to the sum of currents I1 and I4. Similar to the Kirchhoff's voltage rule, it can be stated as sum of all the currents in a junction is equal to 0. N is the total number of branches with currents flowing towards or away from the node. This formula is also valid for complex currents. This law is based on the conservation of charge, whereby the charge, measured in coulombs, is the product of current in amperes and the time in seconds. Applications of these two laws. The current distribution in various branches of a circuit can easily be found out by applying Kirchhoff's current law at the different nodes or junction points in the circuit. After that, Kirchhoff's law is applied in each possible loop in the circuit and generates algebraic equation for every loop. By solving all these equations, one can easily find out different unknown currents, voltages, and resistance in the circuit. So it would be helpful in electrical engineering while designing circuits. Here we can see the examples of applications of those two laws. At this node junction in an electric circuit, the sum of currents flowing into the node, in this case it is the 8 ampere current, is equal to the sum of the currents flowing out of that node. So 8 equals the sum of the 3 and 5 amperes currents. This animation shows a multiple loop circuit which illustrates Kirchhoff's second law, which states that the sum of potential differences as you go around the loop is equal to 0. You can see the smaller two loops and the sum is 0. And on the bigger loop, it's exactly the same. The sum is always equal to 0. In real world application is for monitoring, for example, for monitoring and optimization of power grids, where the engineers in real life monitor, in real time they monitor the current flow in the power lines and adjust it based on their needs. Also, we can find out the application in electronics and in many different situations. Thank you for watching this video and goodbye.